This is a download from BFM 89.9, the business station.
This is the TED Radio Hour. Each week, groundbreaking TED Talks.
TED Talks.
TED.
Technology.
Entertainment.
Design.
Is that really what it stands for? I've never known that.
Delivered at TED conferences around the world.
It's the gift of the human imagination.
We've had to believe in impossible things.
The true nature of reality beckons from just beyond.
Those talks, those ideas, adapted for radio. From NPR. I'm Guy Raz. Coming up,
there will be a new and different form of interaction between humans and machines.
Human-robot collaboration is better than either one working on their own.
Can we adapt fast enough?
I mean, it's not just a new phase of the Industrial Revolution, it's an entirely new revolution.
This episode, the Digital Industrial Revolution. First, this news. It's the TED Radio Hour from NPR. I'm Guy Raz. So robots and machines, they've made our lives a lot better. But one day, maybe sooner than we think, they could also be the end of us, the last thing we humans invent. But before we go there, let's just reflect on how far we've actually come. Because if you look back at the course of human history, for most of that time, the way the average person lived didn't really change all that much.
Until the late 1700s, when Watt developed a much better steam engine.
This is Eric, is it Brynjolfsson, is that right?
Yeah, a lot of consonants all next to each other. In Iceland, they find it very easy.
Eric's a professor at MIT, and the Watt he was referring to, he's talking about James Watt, the inventor of the Watt steam engine, which was basically a really efficient steam engine.
And that ignited what we call the first industrial revolution.
After that, the second industrial revolution, and with it, electricity and the birth of a worldwide economy, which then led to the first machine age, and eventually the information age.
And before that, living standards basically were flat. Since then, they've been growing 2% a year. We're about 30 times richer. So technology, machines, is really, arguably the most important thing that's happened to humanity in terms of our living standards. You could look to the introduction of digital computers in the 1950s.
The electronic central computer.
The personal computer in the 1980s.
On January 24th, Apple Computer will introduce Macintosh.
When machines could first beat humans at games like chess in 1997.
In an absolutely stunning 19-mover, and Kasparov has just simply stormed away.
I think those were all milestones of increasing import, an increasingly large effect on the economy and our lives.
Important because they prove that maybe one day they can be smarter than us?
No doubt about it. I mean, let's face it, they already are much smarter than us in so many things. I mean, try to multiply two 10-digit numbers with each other or, sift through 1,000 documents. So there's lots of things that machines are better at, including in mental tasks, than us. There's many more that they're not as good at, but the direction is pretty obvious and the progress is clear.
On the show today, the Digital Industrial Revolution. Ideas about the economic future we're creating, how we can shape it, and if we'll find a place among the machines. Because if we can eventually create robots to do everything and to do it better, where does that leave us? A future of blissful human-robot collaboration? Possible, yeah. Or maybe something a little darker. Eric Brynjolfsson says right now, we're at the beginning of a new machine age where technology is developing at such a rapid pace that it's kind of hard to keep up with.
It starts with a small exponential trend, and as you know, exponential trends double and double and double, and each time you can barely detect them when they're small, and they start becoming overwhelming. This is the biggest challenge of our society over the next 10 years, is going to be, can we adapt fast enough?
Here's Eric Brynjolfsson on the TED stage.
Computers get better faster than anything else ever. A child's PlayStation today is more powerful than a military supercomputer from 1996. But our brains are wired for a linear world. As a result, exponential trends take us by surprise. I used to teach my students that there are some things, computers just aren't good at, like driving a car through traffic. But perhaps the most important invention is machine learning. Consider one project, IBM's Watson. At first, Watson wasn't very good, but it improved at a rate faster than any human could. And Watson beat the World Jeopardy champion. At age 7, Watson is still kind of in its childhood. Recently, its teachers let it surf the internet unsupervised. The next day, it started answering questions with profanities. Damn. But Watson is growing up fast. It's being tested for jobs in call centers, and it's getting them. It's applying for legal, banking, and medical jobs and getting some of them. Like the first two industrial revolutions, the full implications of the new machine age are going to take at least a century to fully play out. But they are staggering.
How do you imagine the economy of the industrialized world changing over the next 20 to 25 years? Will it be noticeable?
It will be huge. The economy in the next 20 to 25 years are going to change more than they did in the last 20 to 25 years. And that's because these exponential trends are affecting a bigger and bigger share of the economy. So we have some huge disruptions in store. And I can't predict exactly what the innovations are going to be. If I did, I would have already invented them. But I think they'll be comparable to the innovations we saw in the past 20 to 25 years, if not greater.
So like something as significant as the internet, presumably.
I'm sure of that. The Internet of Things sort of doesn't take a lot of creativity to see that coming down the pipeline, where there'll be literally trillions of objects all connected in this digital infrastructure. It's like the Earth growing a skin and a nervous system where all the objects can communicate with each other. And that's just one small part of this new world.
I mean, we could have a future in the not too distant future in which truck drivers are out of work because trucks are automated and driverless, and not just truck drivers.
I think that's likely. I think that's likely.
But
sure.
But university professors, because every case study, every book will be processed by a machine. Every case study of a business problem will be studied by a machine, which will then be able to be a better consultant than a human consultant, better journalists than me, because they will be able to analyze every interview ever done. And that machine could maybe do a better job. I mean, that's not out of the realm of possibility.
It's not out of the realm of possibility, although you got to think about the timelines. It's most useful to think about not jobs, but tasks. And within any given job, there are lots of different tasks. If you're a radiologist, maybe reading the images, machine's going to be able to do that better. Maybe making the broader diagnosis and communicating it to the patients. For a long time, the humans are going to be better at that than the machines. And so different parts of the job will be leveraged. In a way, that's happened for centuries, and we've adapted. And it's made the people who had parts of their jobs automated more valuable and more productive to the extent that they are essential for the other components of their jobs.
But, I mean, do you believe it's possible down the line that we could create an artificial thing of metal and ones and zeros that is more empathetic and exercises better judgment than us and is just all around smarter than we are?
Well, I'm certain of it. There's no question that it's possible. I mean, in between your ears is a proof that there's a physical object that can do all those things. And I don't think there's some ghost in there. I think it's made of atoms and obeys the laws of physics. So we know that it's feasible according to the laws of physics. Are we able to figure it out well enough? I think that's going to be a matter of time.
The new machine age can be dated to a day 15 years ago when Garry Kasparov, the world chess champion, played Deep Blue, a supercomputer. The machine won that day, and today a chess program running on a cell phone can beat a human grandmaster. It got so bad that when he was asked what strategy he would use against a computer, Jan Donner, the Dutch grandmaster, replied, "I'd bring a hammer." But today, a computer is no longer the world chess champion. Neither is a human, because Kasparov organized a freestyle tournament where teams of humans and computers could work together. And the winning team had no grandmaster, and it had no supercomputer. What they had was better teamwork. And they showed that a team of humans and computers working together could beat any computer or any human working alone. Racing with the machine beats racing against the machine. Technology is not destiny. We shape our destiny.
Yeah, I mean, it makes total sense that we are going to be working with machines in ways that we can't even imagine.
Yeah, and I think we'll be working very closely with machines in a couple of different ways. I mean, one is a little bit like the way we're doing it now, where we interact with them, where we ask machines to do some data analysis, and there'll be more and more of a division of labor where we ask the questions and the machines provide the answers. And Pablo Picasso once berated computers saying, well, they're not very interesting. All they do is provide answers. And, he had a point that really the interesting and important part of work is asking the right questions. And that's, for a long time, that's still going to be the domain of humans. Going a little further into the future, we'll start literally connecting to machines. Some of my colleagues at MIT here, some of them are working on a neural mesh that connects directly to your brain. And they've already done it with some disabled people and allowed them to move objects just by thinking. So right now, the bandwidth is pretty slow. You can type maybe, I think it's about 10 words per minute with these brain meshes. But you can see where the future's going with that as well.
I mean, I hate to sound pessimistic because by nature I try to be optimistic. But I ask myself this question a lot, which is, is this the future we want? Have we gotten to a place where the train has left the station, where we don't really have much of a choice about where that future is headed?
Well, let me try and cheer you up a little bit. Let's just step back and look at the fundamentals.
Yeah, please.
What are you and I talking about? We're talking about a world with vastly more wealth, vastly more power to solve all sorts of problems, vastly less need for us to work. Most routine drudgery could be eliminated. Shame on us. Shame on us if we mess that up and turn that into a bad thing. I mean, wouldn't that be the weirdest irony in the world if we take more wealth and less work and say, oh, what a terrible thing? I think we could essentially eliminate poverty from planet Earth. We could cure most diseases. In the global millennium goals, we're on track to beat them and eliminate severe poverty. So there are lots of positive trends. I think the world in 25 years could be a much better version of the world we have today. But the role of humans would still be fundamentally at the center of that.
Erik Brynjolfsson, he's a professor and director of the MIT Initiative on the Digital Economy. You can see his full talk at TED.com. On the show today, ideas about the digital industrial revolution. In a moment, why this is all very, very good and very, very bad. I'm Guy Raz, and you're listening to the TED Radio Hour from NPR. It's the TED Radio Hour from NPR. I'm Guy Raz. And on the show today, ideas about the digital industrial revolution and whether we should be worried or excited.
I am definitely an optimist.
This is Marco Annunziata. Marco's the chief economist at General Electric.
I'm aware that as an economist, being optimistic is kind of out of character, but I feel there are too many gloomy people out there, so I'm happy to do my bit.
One of Marco's main jobs is to predict what our jobs will look like in the future. And he says, not surprisingly, that in the next 5 to 10 to 20 years, almost everything about the workplace is going to change.
There will be a new and different form of interaction between humans and machines, both physical machines like robots and virtual machines like artificial intelligence.
So I don't know if you can take us on a tour of that future. What is a normal person's day going to kind of be like at work? What are they going to experience? How are they going to experience that?
So I think they will experience it in the following way. They will come onto a factory floor. Onto the factory floor, they will find an environment which is a lot more intelligent than today. Everything around the worker, whether it's the equipment the worker interacts with, the different items on the factory floor, will be equipped with sensors constantly sending data to artificial intelligence machines that will be analyzing the data and everything that is going on. There will be robots helping the worker perform whatever functions are involved in the specific job description in a much more efficient and a much safer way. These are applications that make work better.
This collaboration between humans and machines is all part of what Marco calls the industrial internet.
So what is this industrial internet?
He explained the idea from the TED stage.
It brings together intelligent machines, advanced analytics, and the creativity of people at work. Industrial machines are being equipped with a growing number of electronic sensors that allow them to see, hear, feel a lot more than ever before, generating prodigious amounts of data. Increasingly sophisticated analytics then sift through the data, providing insights that allow us to operate the machines in entirely new ways, a lot more efficiently. And not just individual machines, but fleets of locomotives, airplanes, entire systems like power grids, hospitals. Let's start with aviation. Today, 10% of all flights cancellations and delays are due to unscheduled maintenance events. This results in $8 billion in costs for the airline industry globally every year, not to mention the impact on all of us: stress, inconvenience, missed meetings as we sit helplessly in an airport terminal. So how can the industrial internet help here? We've developed a preventive maintenance system which can be installed on any aircraft. It's self-learning and able to predict issues that a human operator would miss. The aircraft, while in flight, will communicate with technicians on the ground. By the time it lands, they will already know if anything needs to be serviced. Just in the US, a system like this can prevent over 60,000 delays and cancellations every year, helping 7 million passengers get to their destinations on time. So we are moving to a world where the machines we work with are not just intelligent, they are brilliant. It's jet engines, locomotives, medical devices communicating seamlessly with each other and with us. It's the marriage of minds and machines, and our lives will never be the same.
Yeah, I mean, it's a complete break from the way humans have lived and functioned since, the beginning of time.
Absolutely, yes. I think we are at the beginning of a massive historical transition which will lead to a new economic system, a new industrial system, a new way of life, which will be really qualitatively different from what we are experiencing now. And I think the impact is going to be enormous.
So, how would you describe where we are today? Are we right at the precipice of this massive change, or are we already in it?
we are already in it, Guy, but we are at the very beginning of it. So for me, a plausible horizon for these new technologies to really spread and transform the industrial system and the economy as we know it, you're thinking of a horizon of 20 to 25 years, but that's for the complete transformation. Within the next 5 to 10 years, you will already see very substantial changes. And I'm saying this because some of these changes are already taking place.
Let's look at the big picture. There are people who argue that today's innovation is all about social media and silly games, with nowhere near the transformational power of the Industrial Revolution. They say that all the growth-enhancing innovations are behind us. And every time I hear this, I can't help thinking that even back in the Stone Age, there must have been a group of cavemen sitting around a fire one day, looking very grumpy, and looking disapprovingly at another group of cavemen rolling a stone wheel up and down a hill, and saying to each other, yeah, this wheel thing, cool toy, sure, but compared to fire, it will have no impact. The big discoveries are all behind us. This technological revolution is as inspiring and transformational as anything we have ever seen. Human creativity and innovation have always propelled us forward. They've created jobs, they've raised living standards, they've made our lives healthier and more rewarding. And the new wave of innovation, which is beginning to sweep through industry, is no different. And I know that many of you will be concerned about the impact that innovation might have on jobs. And innovation is disruptive. But let me stress two things here. First, innovation is fundamentally about growth. It makes products more affordable. It creates new demand, new jobs. Second, there is a concern that in the future there will only be room for engineers, data scientists, and other highly specialized workers. And believe me, as an economist, I'm also scared. But think about it. Just as a child can easily figure out how to operate an iPad, so a new generation of mobile and intuitive industrial applications will make life easier for workers of all skill levels. It's not going to be easy, but it is going to be worth it.
I mean, all of these technologies that are coming online and that will come online and that will, make many parts of our lives more efficient and make our, economies more productive. I mean, they're going to be winners and losers, surely.
There always are. And one thing to keep in mind is sometimes technological innovations have unintended consequences that you need to watch for. So one key example, there's been a lot of attention and focus on the problem of unemployment and the risks coming from automation and artificial intelligence.
Yeah.
Now, to me, that is something that needs to be taken very seriously. Now, I don't buy into the argument you hear that says that in the future, 50% of all jobs will disappear. And that is simply not true. And I think in the end, we will have more jobs, we will have better jobs, but some jobs will be automated away. The transition will be difficult. It will require people to acquire different skills. So how can we get from where we sit today to this brilliant future I'm envisioning where we will all have better jobs, more jobs? How do we get there in a way that creates the least disruption for the smallest number of people? Because there will be disruption. Provided that we manage this transition in the right way, it will definitely be a better future because I work with scientists and engineers and I see what innovation is doing, and that makes me optimistic.
Marco Annunziata is the chief economist at GE. You can find his entire talk at TED.com. On the show today, ideas about the digital industrial revolution and how we as humans will fit into all of it.
So we're going to be, Iron Man plus Spock plus, name your series of superheroes.
This is Maurice Conti.
Yeah, so my name is Maurice Conti. I currently head up applied research and innovation at a software company called Autodesk.
And Maurice is talking about how maybe someday we could all be these sort of superhumans working together with machines in an era he calls the augmented age.
I mean, we've had this partnership with our own technology that has been allowing us to achieve greater things, which I guess by definition is augmentation. I think the difference this time is the speed with which these technologies are coming online and the speed with which we are going to adopt them, which I think will result in something that feels more like augmentation rather than improvement. It's like a superpower.
Okay, so what does it actually mean? I mean, in practical terms, because right now we have access to infinite knowledge, right? We can just pull out our phones and find out really pretty much whatever we want to find out.
Yes, sort of. In fact, I argue that we are already augmented because all of us probably listening have access to a smartphone, which is in turn connected to the internet, which in turn holds vast amounts of information. I wouldn't necessarily say it's knowledge. In fact, that's maybe the next step. The parts that's missing is, yes, I have access to a great body of information, but I still need to turn that into knowledge with my own point of view, my own ability to think synthetically and connect dots.
Yep.
And I think, that's what advanced computation is going to help us with. It's really processing that information, gleaning insight from it, making intuitive leaps and so forth.
And Maurice says that soon a lot of our machines won't just answer questions, they'll actually start thinking. For themselves, coming up with their own ideas and even feeling the world around them. Here's how Maurice explained it from the TED stage.
Tools are making this leap from being passive to being generative. Generative design tools use a computer and algorithms to synthesize geometry, to come up with new designs all by themselves. All it needs are your goals and your constraints. I'll give you an example. In the case of this aerial drone chassis, all you would need to do is tell it something like it has 4 propellers, you want it to be as lightweight as possible, and you need it to be aerodynamically efficient. And then what the computer does is it explores the entire solution space, every single possibility that solves and meets your criteria, millions of them. But it comes back to us with designs that we, by ourselves, never could have imagined. And the computer is coming up with this stuff all by itself. No one ever drew anything, and it started completely from scratch.
Okay, if the future is going to be a future of artificial intelligence, do you think that we're going to figure out a way to work together? Or, or not?
Well, part of me says that has to be true. The AI was built and is operating in service of some goal that I was trying to achieve. And if I'm achieving that goal, then I think by definition I'm in partnership with that AI.
So,
feel free to call bull on that.
No. I was saying this to Eric Brynjolfsson earlier in the show, right? That I cannot imagine any single profession, including professions that we think require a whole lot of brain power, like psychiatry. Okay, I cannot think of a single profession that couldn't be displaced by a machine learning machine that just becomes smarter and smarter and smarter.
Yeah, certainly it's easy to imagine how just about every profession can be affected by these technologies. Where it gets interesting is if we start to debate, will these professionals be displaced? And certainly in some cases they will, but I think in many cases they won't. And part of the reason is there's this graph that I like to draw, and it has 2 curves on it. The first curve is an upward exponential curve that represents our
capabilities as a species based on the development of technology. So perhaps at some point when we reach a very high point on that curve, we'll be done. There'll be nothing else to do. What I think a lot of people overlook is there's another curve right next to it that happens to be in lockstep, and that is the curve of opportunity. And it's actually easy to see, whenever some company comes out with the latest smartphone, the next day people are like, great, what's next? I want more. Mm-hmm. And I think it's the fact that we have this other curve, which is our capacity to imagine and desire better things, better lives, better relationships, that will keep the demands on us increasing. And if that's true, then the AIs that would displace us are actually just what we need in order to keep up.
So as computers are going to augment our ability to imagine and design new stuff, robotic systems are going to help us build and make things that we've never been able to make before. But what about our ability to sense and control these things? What about a nervous system for the things that we make? Our nervous system, the human nervous system, tells us everything that's going on around us. But the nervous system of the things we make is rudimentary at best. For instance, a car doesn't tell the city's public works department that it just hit a pothole at the corner of Broadway and Morrison. A building doesn't tell its designers whether or not the people inside like being there. And if the designers had known what was really happening in the real world with their designs, they could have used that knowledge to create an experience that was better for the user. Now, what's missing is a nervous system connecting us to all of the things that we design, make, and use.
I mean, a nervous system, a human nervous system is such a complex thing that it's hard for me to get my head around the idea that there could be a comparable digital system.
I think when a lot of people think about AI and things like Skynet, one of the things they assume is that the AI is aware. And I think awareness is a prerequisite of powerful, useful AIs. And so giving AIs a nervous system, the ability to perceive their environments in order for them to carry out their jobs, is critical. And that's already happening. This isn't science fiction at all. It's just a question of getting sensor data from the real world into the AI. It's happening in your car every day. If you have a car that has any kind of autopilot or fancy cruise control, it's looking around it, it's perceiving its environment, and then making decisions based on that. And so really it's just a continuation of that. More sensors, more real-time data coming in that allow the systems to make relevant decisions that are helpful to us.
So, I mean, we've heard stories about this on the show already about how, when humans and robots work together, everybody wins. Is this idea that human AI collaboration, is infinitely superior to everything else out there? I mean, is that always going to be the case, or is that just wishful thinking?
No, I think human technology, human AI, human robot collaboration is better than either one working on their own. I actually think that's a tautology. Humans are very good at some things. Synthetic systems are really good at others. All else being equal, I cannot imagine the argument where the combination of these two skill sets is not better. And that's where it gets interesting, because the AI is currently not that great at intuition, but really good at sort of brute force computation on tons and tons of data. And it's a little bit like a dance. The human might lead, but the computer can do lots of fancy moves that together combine into something that is greater than the sum of its parts.
Maurice Conti, he's the Director of Applied Research and Innovation at the 3D design and engineering software company Autodesk. You can see his full talk at TED.com. On the show today, the digital industrial revolution. In a moment, a question. Is it possible we're inventing the last human invention? Stay with us. I'm Guy Raz, and you're listening to the TED Radio Hour from NPR. It's the TED Radio Hour from NPR. I'm Guy Raz. And on the show today, ideas about a new industrial revolution.
I mean, it's not just a new phase of the Industrial Revolution. It's an entirely new revolution.
This is data scientist Jeremy Howard.
So we went through the process of replacing hunting and gathering with domestication. We went through the process of replacing animal energy with mechanical energy. We're now going through the process of replacing human intelligence with artificial intelligence.
So for the past 25 years, Jeremy has been working on a technology called deep learning, and it's based on the way the human brain and nervous system work.
Deep learning relies on a particular kind of function called a neural network. It is heavily inspired by neuroscience and can actually compute anything.
Anything, because these machines can learn and perceive, they can see, hear, read, write, they can make decisions, all while being able to process billions of data points.
It's creepy and it's possibly about to get creepier.
Oh, no. But before we get to the creepy part, we should point out we're already using these neural networks for a lot of pretty cool things.
So today we have 1,000-layer neural networks doing things like Skype translation. I don't know if you've tried that.
Yeah, we just actually tried it.
Hey, can you hear me?
Et peux-tu m'entendre?
Oui, bonjour. Nous vous entendons très bien.
Yes. Hello. We hear you.
Okay, let me explain what's going on here. Our producer, Casey, is speaking into Skype.
Okay, great. So you're recording?
Obviously in English, and Skype is translating that in real time into French.
Super. Alors tu enregistres.
And on the other end is Mathilde.
Oui, on enregistre.
Except she's speaking in French, and Skype turns that into English.
Yes, we're recording.
And how does this work?
The basic approach is that you download lots of sentences that are written both in English and French. You basically write 3 or 4 lines of code, and you then tell that neural network where to find the input and output data, leave it overnight, and come back in the morning and see if it works. So a sentence could be, please enter your username here.
Veuillez entrer votre nom d'utilisateur ici.
It learns to map at a very deep and subtle way, such that the next day I can then put in a different sentence. What is the world's largest country?
Quel est le plus grand pays du monde?
And Jeremy says that's all it takes. You start with simple sentences.
Quelle est la distance entre la Terre et le Soleil?
What is the distance between the Earth and the Sun?
As you keep going, the program keeps learning on its own.
Quelle est la population de la ville de Paris?
What is the population of the city of Paris?
To the point where you can have entire conversations translated.
Hey, good morning. How are you doing?
Salut, bonjour, comment allez-vous?
In real time.
Ça va bien, merci.
By a machine.
I'm fine, thank you. How's your family? Have you talked to them?
Comment va ta famille?
I mean, this concept is absolutely incredible, right? Because with this technology, once you hit go, it's unstoppable. I mean, it just continues to get better and better and better, right?
Right. So you set up your problem and you run it overnight and you come back the next day and hopefully it solved it. Now, it's pretty hard to describe exactly what it's done, and often, very, very often, I don't really understand at all how my programs work. A few years ago, I built a system for diagnosing lung cancer, which could beat a panel of 4 of the world's best radiologists, but I know nothing whatsoever about what lung cancer looks like or doesn't look like, and could tell you nothing about how it worked because I have no background in medicine. So that's the nature of setting up these things. You fire them off and they come back with a model.
And Jeremy says diagnosing lung cancer is just the beginning.
And so you can imagine the power that this provides for good. Every time a piece of medical imaging is done, automatically and instantly an alert appears saying this person has an aneurysm or this person has a malignant nodule in their left lung. You know, that would be saving millions of lives and billions of dollars.
Here's how Jeremy explained it from the TED stage.
This kind of technique could allow us to fix a major problem, which is that there's a lack of medical expertise in the world. The World Economic Forum says that there's between a 10x and a 20x shortage of physicians in the developing world. And it would take about 300 years to train enough people to fix that problem. So imagine if we can help enhance their efficiency using these deep learning approaches. So I'm very excited about the opportunities. I'm also concerned about the problems. The problem here is that every area in blue on this map is somewhere where services are over 80% of employment. What are services?
Okay, so at this point in his talk, Jeremy pulls out a large world map, and he explains that in most of the developed world, and even in a lot of developing countries, their economies depend mainly on service jobs. People who prep food and drive cars and file documents, do legal research, even diagnose disease.
These are also the exact things that computers have just learned how to do. So, 80% of the world's employment in the developed world is stuff that computers have just learned how to do. What does that mean? Well, it'll be fine. It'll be replaced by other jobs. For example, there'll be more jobs for data scientists. Well, not really. It doesn't take data scientists very long to build these things. For example, these 4 algorithms were all built by the same guy. So if you think, oh, it's all happened before, we've seen the results in the past of when new things come along and they get replaced by new jobs, what are these new jobs going to be? It's very hard for us to estimate this because human performance grows at this gradual rate. But we now have a system, deep learning, that we know actually grows in capability exponentially. So currently we see the things around us and we say, oh, computers are still pretty dumb, right? But in 5 years' time, computers will be off this chart. The better computers get at intellectual activities, the more they can build better computers to be better at intellectual capabilities. So this is going to be a kind of change that the world has actually never experienced before. So your previous understanding of what's possible is different.
I mean, the fact is that machines are getting better and better as we speak, second by second, in being able to process billions and billions of pieces of data, and they're just going to get better and better next month and in a year and in 5 years and 20 years. And they are going to be able to make decisions in ways that will be confounding to us.
I mean, so I did my TED Talk 2.5 years ago, I guess. And at this point, computers are better at recognizing what is in a photo than humans are. They are better at understanding Chinese and English speech than Chinese and English native speakers. We now have deep learning algorithms that are better at building the neural networks that create deep learning algorithms than humans are.
God.
So 2.5 years since I got up and said, hey, there's this new technology called deep learning which is about to surpass human capabilities in these fundamentally human areas. Between then and now, it happened.
Do you think we can even articulate or imagine what this technology will do to change our world, our lives, our species?
Not only is it impossible for us to imagine, there is a great many things which are stopping us from being able to imagine it.
Like what?
So people often talk about exponential technologies, but the fact is, every technology that's come so far is actually an S-shaped technology. Mm-hmm. Before electricity, nearly everything that required an input of energy was done with human energy or horse energy or something like that. Then we learnt how to electrify nearly every energy-requiring process until eventually we did them all. And so there was initially exponential growth as the newly electrified processes allowed us to improve other processes, but then it flattened off again. Now, on the other hand, think about replacing intellectual power, right? There's no S-curve here. There's no drop-off. There's no point where you go, okay, we've now used all of the intellectual power that can be used. So our ability to actually understand the outcome of a truly exponential technology cannot be based on anything that has been observed in history, because there's never been a technology like this before.
Yeah, I mean, it never stops. It doesn't reach a point where we say, right, okay, next, we've reached that milestone and now we can just move on to the next thing.
Right. Well, that's the thing, right? This is kind of the last human input is kind of perception and intelligence. So a lot of people then say, oh, yeah, so there'll be new jobs. But then you say, like what?
Yeah.
And that's where people come up short. Like, you could tell, even in the Industrial Revolution, you could say, okay, electricity can't do all of these things. Look at things or listen to things or react to things. That's not where we are anymore. We're now in the process of saying, okay, this is the last bastion of stuff that only humans can do.
Yeah, I mean, I've been asking everyone on the show this question, and, they seem pretty convinced that, we humans will continue to have jobs. Like, you and I will continue to do what we do, and will continue to be necessary as a species. But I'm not really so sure.
Yeah, there's no question that the vast majority of things that humans are doing today are going to be replaced. And it's also important to remember, though, that the vast majority of people have jobs that kind of suck, right? It's far more people who are chopping celery for a living than there are people running TED Radio Hour for a living. So given that we both agree that the jobs that we have today are going to disappear probably quicker than anybody expects, that means that we need to have ways of supporting people economically. Because you can't just say you're not adding value, so therefore you're not worthwhile to society. You actually have to say, okay, we think everybody deserves to live in dignity, so let's have a basic guaranteed income, which is enough to ensure that every human can have a life of dignity.
I mean, do you think we're like designing our replacement? Because you could imagine a point when, we won't be the most intelligent species on the planet. Like, we would still live on it, we would still reproduce, but
right.
But I mean, intelligent machines will create a new economic model and a system of governments for us on our behalf. We're going to be like zoo animals.
Yeah, I don't think that's too hard to imagine. If we continue down this path where more and more of the economy looks like the inside of a Amazon logistics warehouse, where every human being, every move they're making is being supervised by and rewarded or penalized by machines, until we're all at the beck and call of the machinery. And we could well look at each other and go, none of us signed up for this.
Yeah.
None of us designed this.
It's just hard for me to wrap my head around this idea that, we have consciousness. I mean, even though we're not sure what exactly animates us, right? But I just have trouble believing that, one day we're going to develop machines that think and feel and act like we do.
The more I use this technology, the less my own consciousness seems surprising or inexplicable.
Really?
Very much so.
Wow.
Once you've used these kinds of tools for long enough, you just keep seeing them behave in certain ways that just looks very familiar.
But you're basically saying that the ones and zeros in a machine are very similar to the ones and zeros in your brain.
Well, clearly. I mean, it has to be true. The alternative is if you believe that there's a God and there's a soul and it's this ineffable thing we can't see or touch.
Yeah.
Okay, that's fine. I can't and I'm not going to argue with that because it's based on faith, not science. Unless you believe those things, you have to believe that the chemical and electrical signals and connectivity in our brain is us. The idea that these kinds of massively parallel, massively connected functions inside huge computer systems can display intelligent behavior, well, we're already there. We just keep redefining intelligent behavior so that, we're always outside it.
But I mean, as a human, I can emote. I can feel things, like I understand my mortality. I love, I feel grief. I mean, how are those things replicated by, in a machine by ones and zeros?
Very, very easily. Huh. All of the things you're describing are rational evolutionary responses to a fitness function that attempts to keep your genes alive.
Huh.
The reason you love is because your genes want you to have sex and have more of those genes. The reason that you grieve is because your genes want you to avoid doing things that cause people with similar genes to yours to die. All of the things that you emote are at some level evolutionary responses to this fitness function of keeping your genes going for longer. So as our complex computer-based functions get better at figuring out what causes their fitness functions to be successful, they will have all of these very complex interactions.
I'm not walking away from this conversation optimistic. I'm troubled.
Good.
Yeah, I'm troubled.
Good. Be troubled.
Yeah.
You know, being troubled is the correct response, but also excited. Be both. Because all of these people who say, don't worry, everything's fine. There will always be jobs. Just feed the robots, feed the machines, don't worry. To me, they're just the same as climate change deniers. You know, they're ignoring the basic science that says this is something different, this is something we can't control, this is something we don't know where it's going, and this is something which can definitely have terrible societal outcomes. On the other hand, anybody who says the government should step in and regulate and control and stop all of this from happening, people shouldn't be doing this kind of research, they're just as bad. You know, they're saying the billions of people that don't have access to modern medicine should never be given it, even though we have the technology today to provide it. So we need to be both. We need to be aware of the opportunities and aware of the threats.
Jeremy Howard, he's a data scientist and the founding researcher at Fast.ai. It's a company dedicated to making deep learning accessible to everyone. You can see his entire talk at TED.com. Hey, thanks for listening to our show on the digital industrial revolution this week. If you want to find out more about who is on it, go to TED.npr.org. To see hundreds more TED Talks, check out TED.com or the TED app. Our production staff at NPR includes Jeff Rogers, Sanaz Meshkinpour, Janae West, Eva Grant, and Rachel Faulkner, with help from Ramteen Arablouei and Daniel Shukin. Our intern is Thomas Liu. Our partners at TED are Chris Anderson, Kelly Stetzel, Anna Phelan, and Janet Lee. I'm Guy Raz, and you've been listening to Ideas Worth Spreading right here on the TED Radio Hour from NPR.
Thank you for listening to this podcast. To find more great interviews, go to bfm.my or find us on iTunes. BFM 89.9, the business station.